Alright guys, let's look at lesson 4, which is properties and changes of matter. First, let's talk about your states of matter. There are solids. They have a definite volume, definite shape. Their particles vibrate in place, and they have a symbol of S when we write them in a chemical formula or in a chemical equation. There are liquids. They have a definite volume. They take the shape of the container. They are constantly in motion. They have a symbol L, which means a liquid, or aqueous, which means they're in a water solution. We have gases that have no definite volume. They fill the container, or they spread out to fill their container. They're compressible because they have so much space between them. We can put pressure on them and move them closer together. They have the greatest amount of movement. They move the fastest. And in equations, we write them with the symbol of G. There's two more that we need to talk about, and these are two that you might not be as familiar with. Plasma. They are ionized particles that are out in space. They have no definite volume. They spread out to fill their container. They are compressible. They have the greatest amount of movement, even more so than gases do. And they have a symbol of P. And these exist only at high temperatures. So like I said, you won't find plasmas here on Earth that much. You'd find them out in space. And Bose-Einstein condensates is the last one. They exist at extremely low temperatures, near 0 degrees Kelvin, absolute zero. And what happens is that the particles kind of lose their identity, move together, and become one super particle, one super atom. And it kind of is no longer going to move like a particle, it's going to move like a wave. And we will abbreviate those as BECs. And so here we have our normal particles, and as we drop our temperatures, they become more, not necessarily particles anymore, and then eventually they become into this huge wave that we know as a Bose-Einstein condensate. So how do you determine the phase of matter at standard temperature and pressure? For these exercises, we are not going to talk about plasmas and Bose-Einstein condensates. We are going to talk about the standard solid, liquid, and gas. So at different temperatures, the substance can be in a different phase. And the scientists determine the normal conditions of temperature and pressure to be called the standard temperature and pressure. Standard temperature and pressure is in Table A in your reference packet. The standard pressure is 101.3 kilopascals, or 1 atm. We're predominantly going to use 1 atm. And then temperature is 273 degrees Kelvin, or 0 degrees Celsius. So we can use Table S to determine the phase of matter at standard temperature and pressure. So I want you to think about it this way. If you're looking at your melting point, if the temperature is lower, meaning the standard temperature and pressure, so 273 degrees Kelvin, is lower than the melting point, it has not melted yet, which means that it will be a solid. If the temperature is higher than the melting point, that means it already melted, and it's going to be a liquid. And then if the temperature is lower than the boiling point, but has not boiled yet, it's a liquid. And if the temperature is higher than the boiling point, it will be a gas. So we can look at it. So for example, at standard temperature and pressure, what is phase of matter of boron? So I've highlighted boron. This is from Table S of your reference packet. And the melting point of boron is 2,348 degrees Kelvin. Standard temperature is 273 degrees, so it's less than that. And since 273 degrees is less than 2,348 degrees Kelvin, boron will be a solid at standard temperature. So let's look at a practice. What if I ask the same question about lithium? So let's look at the Table S. And lithium has a melting point of 454 and a boiling point of 1,615. So pause, think about this for a little bit, and then unpause the video when you're ready. So your thought process should have went as follows. You should have thought to yourself, okay, well, lithium has a boiling point of a melting point of 454 degrees Kelvin. So since 273 degrees Kelvin is less than 454, lithium is going to be a solid. All right, let's look at this. Check your understanding. What state of matter is mercury at standard temperature and pressure? We're going to talk about this first thing tomorrow. But we have more things to continue to talk about, so let's keep going. So let's talk about physical properties and changes. These are characteristics that don't change the substance, so no new substance is being formed. So density, crushing, solubility, melting point, boiling point, phase changes, all of those things are physical property and also result in physical changes. Signs of a physical change or property would be that you still have the same substance, but it's in a different form or state of matter. So when you want to identify that a phase change has happened, you need to look for certain words like dissolves, melts or boils, is a solid, a liquid, a gas, or something along those lines. If it's a chemical property, the characteristics that change the substance. So something new is made, a new substance is made. So reactivity, flammability, corrosiveness, those are examples of chemical properties that can lead to chemical changes. Signs of chemical property or changes. So if a new substance is made that has different properties than its own elements that make it. So for example, if you look and see bubbling, that means that a gas was formed. And if a gas was formed, that means that you made something new, so that would indicate that a chemical change has happened. So words to look for when you're trying to identify whether a chemical change has occurred would be reacts with, or combusts, or corrodes, something along those lines. So let's try and identify the type of change. So I want you to pause the video, go through and identify these on your own, and we'll go through them when you're finished. Great, well, welcome back. What did you come up with? So rusting iron, you should have said, was a chemical change. Dissolving in water, you should have said, was a physical change. Burning a log, you should have said, was a chemical change. Melting of ice, you should have said, was a physical change. And crushing a compound, you should have said, again, was a physical change. So let's look at this, check your understanding. Is the following a chemical or physical change, and why? So we're talking about ice melting into liquid water. We're going to talk about this first thing tomorrow. And we're also going to talk about this, check your understanding. Remember, this is from the first half. What state of matter is mercury at standard temperature and pressure? Okay, great. I'll see you tomorrow.